Okay, so we're back here finishing up chapter 16. Where's my textbook? This is not good. Oh, here's my textbook. Okay, so what we're doing in chapter 16, we're going to go back and we're going to look at the book here and do one more problem from the book. And we're going to be on page, it would be helpful if I was organized here, but once again, I really don't care. All right, page 383, and we're going to do number 23. The number 23 says random variables, given independent random variables with means x and standard deviation is shown, find the mean and standard deviations of those variables. Now, it's really important that we look at this statement and we see independent random variables, because what we're going to end up doing is we're going to taking distribution x and distribution y, and we're going to end up combining them. And it's really important that they are independent, because if they're not independent, then we cannot work with the standard deviations, and that's really important. They have to be independent, and it says they are independent there in the question. So what we have here, as we look at this, and I want to go with the color blue because it's much better for me. All right, so here we have a mean and a standard deviation for distribution x and distribution y, and the mean for distribution x is 10 and the standard deviation is 2, I think, yep it is, and for y we're looking at 20 and the standard deviation is 5. And the very first problem A says, okay, so what we've got is we've got 3 times distribution x. Now it says random variable. But really what we have here, if we think about this, what we have is we have an entire distribution of numbers, and as a random variable we're talking that you could randomly select a piece of information from this distribution. This is what we know about the distribution. We know that the distribution has a mean of 10 and a standard deviation of 2. If we would think about this as a distribution, we would say, oh, we're going to guess that this distribution is normal with a mean and a mean of 10 and a standard deviation of 2. And that's really what this is telling us. So when we're sitting there saying, okay, well what we're going to do is we're going to pick 3 times a random variable x. But really what we're saying is, we're saying, okay, let's take the entire distribution, multiply it by 3, and then we're going to pick a value out at random. Because what we need to do is we need to find the mean of 3 times a random variable, or 3 times the distribution. At this point, what we say to ourselves is this. We're taking a look at mean, and we say, okay, does the mean, or does, that's good grammar, is the mean affected by this multiplication? And then we go back to what we said about distribution. Is the mean affected by the multiplication of the distribution? The answer is yes. So what this means is this is 3 times the mean of x. Our mean happens to be 10. So this is 3 times 10, or 30. Yes, it is that simple. Okay, the other thing we need to do is we need to find the standard deviation. So I would write the standard deviation of 3 times the random variable x, or 3 times the distribution of x. I say to myself, is the standard deviation affected by this multiplier? Yes, standard deviation is affected by multiplier. So this is 3 times the standard deviation of x, or 3 times, what's the standard deviation? 3 times 2, which is 6. We've done this before, and that makes it really convenient. Okay, so now I'm going to erase this because I want to keep this information here. I'm going to erase this, and we're going to go to part B of this. So, erase, 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 and we go to B. And let's make sure the pen's here, good. Okay, B says y plus x. Okay, so now what I have is I have another normal distribution, but it's y. The mean of this distribution is 20. The mean of the standard deviation of this distribution is 5. What? That's not y plus x, it's y plus 6. Undo, undo. Undo, undo. Y plus 6. Okay, so what I'm going to do is I'm going to take the mean of distribution y plus 6, and I say to myself, okay, so now I'm going to take the entire distribution, I'm going to add 6 to it, take the random variable, it's a distribution. I'm going to take the distribution of y, I'm going to add 6 to it, and I want to find the mean of that. So I say to myself, hey, is the mean affected by the addifier? And the answer is yes, it is. So what this is the mean of y plus the constant of 6. What's the mean of y? The mean of y is 20 plus 6, 26. We've done this before. Standard deviation of y plus 6. So I ask myself, I'm going to take the entire distribution of y, I'm going to move it 6 places to the right, and I say, does the standard deviation change when I add that constant to it? Does the standard deviation change by the edifier? No, it doesn't. So this is the standard deviation of y, which is 5, does not change by the edifier, is not there. We're done. Is it that easy? Yes, it is. All right, let's go to C.
Yay! I like C. I like C too.
All right. C is x plus y. I don't want to do that one yet. I'm going to make up B sub 2. B sub 2. And we're going to pick a distribution. We're going to say, okay, what about 3 times x plus 4? All right, so here's what I'm going to do. I'm going to start off by saying, what's the mean of 3x plus 4? And I say to myself, hey, does the mean change by the multiplier? Yes. Does the mean change by the edifier? Yes. So this is 3 times the mean plus 4. The mean of x is 10, so this would be 3 times 10 plus 4, 34. What about the standard deviation? Standard deviation of 3x, that's an x, 3x plus 4. Does the standard deviation change by the multiplier? It most certainly does. 3 times standard deviation of x. Does it change by the edifier? No, it doesn't. So this is 3 times the standard deviation of x, which is 3 times 2, which is 6. We've done this. We can do this. This is not hard. Erase. All right, so C says distribution x plus distribution y. So now I'm going to combine the distributions. And this is really important where it says they are independent, because first thing we're going to talk about is the mean of x plus the mean of y. And what we said, if I have distributions, I can combine or subtract the means. And we gave the example of the SAT math and the SAT verbal scores. I can combine those. So all I have to do is I just have to add the means of these distributions. The mean of, whoops, and actually this is, we're going to start this off the right way, because that's the next step here. Because really what we're talking about here is we're starting off with, I want to find the, that's good, I want to find the mean of x plus y, which is the mean of x plus the mean of y. I can combine the distributions. So this is 10 plus 20, which is 30. Okay, fine. Now we're going to do the standard deviation of x plus y. And what we said with the standard deviation is that I cannot combine standard deviations because that last step of square root screws everything up. So what we need to do is, instead of finding the standard deviation, we need to work with the variance, which is the standard deviation squared. And I'm going to work with the variance, and I can combine the variances. And of course, variances always add, which will come up in a minute, but variances always add. So this is going to be the variance of x plus the variance of y, which is the standard deviation of x squared plus the standard deviation of y squared. And what we said, and I'm going to change the color here, is that this is exactly like the Pythagorean theorem, because this is c, and c squared, the hypotenuse, is equal to leg 1 squared plus leg 2 squared of the right triangle. And it's completely legitimate to sit there and think, oh, I've got a right triangle, and this is the standard deviation of x, and this is the standard deviation of y, and this is the standard deviation of distribution x plus distribution y. So what I'm going to do is I'm going to square this one, and the standard deviation of x is 2, so I take 2 squared. Standard deviation of y is 5 squared, and I would say, okay, 2 squared plus 5 squared, go away. 2 squared plus 5 squared is equal to, I'm running out of room here, 2 squared is 4, change the color to purple, this is 4, 5 squared is 25, 4 plus 25 is 29, so c squared is equal to 29. But I'm not done, because my answer is not 29, That is the variance. So I need to take the square root of 29. So this distance right here, this hypotenuse, is the square root of 29. So the standard deviation is the square root of 29, and the square root of 29 is going to be 5 point something. Well, let's find out. I've got my calculator here. Really, I do. All right, come on, come on. All right, so standard deviation of, square root of 29 is, to 2 decimal places, 5.39. So 5.39 is our answer. Okay, coming back after the break to finish this up.